Happy Wednesday morning, friends. Welcome to Module 3, Lesson 14. If you're going to enjoy this video, please like and subscribe. Turn that bell notification on if you so please. Sorry, just had to be a little cringy this morning because I'm a YouTuber now, right? I got my mic. I post on YouTube. So there's my bad joke of the day. And you thought you could get away with it without being around me today. So today we're going to be trying to add and subtract fractions again, but we're going to kind of look for patterns and ways to group them so that we can do the work mentally. And I know that earlier in the week I thought I was going to do 14 and 15 today, but I made a mistake when I was looking up the lessons. I thought 14 and 15 were the same kind of lesson and I could group them together, but 15 is all word problem practice. And we're just going to kind of miss that because I need to do the assessment Thursday, Friday, so that everything lines up for moving forward. So with that said, we'll get right into it then. Okay, so let me minimize my face and let's get into this. All right, what I'd like you to do is write this expression. Let me get my background color on. And let's write this. I want four fractions. We're going to write four fractions. And the first one we're going to add. So let's do 2/3. Goodness. Plus 1/5. Hold on. I'm going to pause this and I'm going to go see if I change tips on my stylus, if that fixes this. All right, let's try this stylus. Let me clear this. 2/3 plus 1/5. Oh, there it is. It was my tip the whole time. 2/3 plus 1/5 plus another third plus 1 4/5. Now, a couple things I want you to notice, or at least one thing I want you to notice. Whoops, I thought I grabbed the highlighter. Notice how my whole number is the same size as my fraction pieces. So that way, when we look at this expression sentence, we can easily see that whole outside of the fractions, and it's not mixing in and we're not getting ourselves confused. So the first question is, what do you notice about this expression? I have 2/3 plus 1/5 plus 1/3 plus 1 4/5. And if you're kind of like, what Briggs? I see four add-ins. We're adding four fractions. Well, look at the units. What do you notice about the units? Well, we have thirds, right? And then we also have fifths. So what we're going to do is we're going to rewrite this sentence because we know addition. We can change the order of the add-ins and get the same answer. That's the commutative property. So what we're going to do is we're going to just rewrite this expression using parentheses and grouping our like units. So 2/3 plus 1/3. I hope you already see what that answer is. Plus 1 4/5 plus 1/5. Now you could have said 1/5 plus 1 4/5 and done it in order. I just like using the larger number first. That's kind of how I thought about it. So if we're thinking about this, and we should be able to hopefully do this in our heads, but we see 2/3 plus 1/3. When we get that together, we should have 3/3. Well, that's really just one whole. Well, over here we have 1 whole and 4/5 plus 1/5. Well, if we add the fifths together, we get 5/5, which is another whole. And then we have 1 plus 1, so that should be 2. So the answer to this long expression that looks like 2/3 plus 1/5 plus 1/3 plus 1 4/5, which is scary when you look at it, when we actually analyze the units and we analyze the fractions and we group them in ways that make it easy for our brain, this math problem just became a little bit simpler and a little bit more straightforward. And that's the power of math, when we can rearrange and work on things like that. All right, let's try that again. But this time, let's see what happens when we subtract. Like it was kind of simpler when we just are grouping them up and adding them together. So let's think about a subtraction expression. So write this down. 5 7/8 minus 1/2 minus 7/8 minus 1 1/2. Again, what do we notice? Kind of thinking about the same thing. We have eighths and we also have halves. So it looks like we can group some pieces up. But when we were adding, we didn't really have to worry about the sign. We just knew that we were all grouping them together, and the commutative property states that we can, rearrange and add them in any order and we'll still get the same answer, but subtraction's a little different. We kind of have to think about the fraction with the operation in front of it, right? So see how I circled them to have the subtraction sign with it? We need to kind of think about that while we're doing this. All right? Because that will help us guide this. So, well, let's combine. Oops, I hate when I stay on the highlighter. 5 and 7/8. We're going to combine those with the other eighths. So 5 and 7/8 minus 7/8. I hope that you can see it. But then we're also subtracting another part because but now this is the harder part because it was easy to say, well, we're starting with this whole number, right? So what do we put in this next box? How do we combine the 1/2 and the 1 1/2? Because we're subtracting both of those numbers from the 5 and 7/8. Does it make sense to subtract them from each other? Or are we subtracting both of these fractions from the whole? Yeah, we're subtracting both of the fractions from the whole. So really, we're going to show a subtraction, but what we need to do is we need to group these two together to be able to subtract it from the whole. Now, but because we grouped it together, we're still subtracting. We can see that over here in this symbol right here. But we needed to lump them together before we subtracted and made it easy for our brain. So let's think about this. 5 and 7/8 minus 7/8. Well, if we take away the 7/8, we're just left with 5. And then if we think over here, 1/2 plus 1 1/2. Well, if we add the halves together, we get another whole. And then we get 1 plus 1. So we're really saying this problem is 5 minus 2, which we know is equal to 3 wholes. Awesome. Now, there is a way you could have done this math problem a little different, but I like the idea of us lumping these common groups together and working from there. So I'm only going to show you this way today. Let's do one that has some addition and some subtraction and see what that means. And then we'll do one that has a missing addend. So let's do 2 and 5, 6. We'll start with the addition and subtraction one. But we're going to subtract 1/3, but we're going to add at the same time 1/6. So we are going to subtract 1/3, but add 1/6 to 2 and 5, 6. So the question becomes, how do we regroup this? Well, we see 6s and 6s. But again, this is where we have to kind of think about the operation that goes in front of the fraction. So it's saying that we're adding 1/6 to whatever we get. So let's go ahead and just rewrite this as we're adding the 6 first, and then we'll subtract the 1/3. So now if we think about it like this, well, 2 and 5, 6 plus 1, 6. So that's easy in our head because we can just say, well, 2 and 6, 6 is 3. This gets scary when you're like, oh my God, I have to create all these common units. But do you? Let's analyze it and let's see if there's any patterns where we can get to some whole numbers or benchmark fractions that are very easy to work with. Well, when we now minus 1/3, okay, well, this one was a little bit extra work because we have to think as 3 as 2 wholes and then 3 and 2 3/3, right? Because 2 plus 1 is 3. Well, that's really all that's saying. So our answer should be 2. And then if we take one of those thirds away, we'll be left with 2/3. Okay. So we just have to think about the when we have two different operations in the expression, we have to think about which operation goes with which fraction and keep that organized when we're reordering. So good job. Just like we did here. We kept the addition with the 1/6. Okay, so what happens if I give you a math problem like this? Let's do 6 3/4, whoops, 6 3/4 plus 3/5 equals 5. Oops, I'm sorry. I missed this a step. That wouldn't have made sense. Minus blank equals 5. So how do you figure out what that underline is? We have to subtract something to get us to 5. So really, what we're going to do is we're going to think about how we can do this with algebra, okay? Because we have to think about how to get this blank by itself. So we know that this side, because it's an equal sign, needs to equal 5. So if we take this part of this equation and subtract that 5, we should be left with the part that gets us to 5. So let's go ahead and try that. So let's rename this 6 3/4 plus 3/5. But this time we're going to subtract the 5, and then we're going to equal what we're missing. The problem with this one, comparatively to the ones that we've practiced so far, is we do not have common units. And if we count by 5s, 5, 10, 15, 20, 25, is there any of those that's also a multiple of 4? The answer is yes, and it would be 20ths, right? 4, 8, 12, 16, 20. So let's convert them to 20ths and see if we can do this in our head. So we know that both of these fractions we want to 20ths. Well, what did we have to do to 4 to get to 20? So we had to multiply by 5. So we always do that to the top as well. 3 times 5 is going to be 15. And then what did we do to fifths to get to 20? We multiplied by 4. So 3 times 4 is 12. And then we're going to subtract 5. Okay, well, let's work on inside of that parentheses now. Let me, whoops, cancel. Let me scroll down. Well, what's 15 plus 12? I'm just going to do it over here so you can see it in your head. It's 27. So this is saying 6 27 20ths minus 5 is equal to what we're looking for. Well, that's a fraction greater than a whole. So let's pull out 20 20ths and make it one more whole. That should leave us with 7 20ths minus 5, which equals, can you do this now? Well, what's 7 minus 5? Well, it's 2. Nothing changed with our fraction because that wasn't a common unit. It was ones and ones. So we have 2 and 7 20ths. Now that's a challenging problem. Multiple steps, multiple kind of hard thinking. You're really doing algebra because in high school, what they would do is they'd put an X there or a letter and say solve for X. Well, that's exactly what you just did. You solved for X. You did some algebra with this kind of question. So that's a really challenging question. So good job working through it. And there'll be a couple of those on the the problem set. So my video is already a little long, I can tell just by feel. So I'd like you just to do the first page and try to group your common units. Let's just take a look if there's any of those missing factors on this one. Yeah, there is on the bottom 2 problems. Okay, so let me also import the exit ticket real quick. I think it's just 2 problems. I don't think there's any missing terms. Let's take a look. No, they're both missing terms. All right, with that said, let's do those 2 together, then I'll let you do the rest on your own. Let's make sure you feel comfortable with these 2 skills down here. So fill in the blank to make the statement true. We're going to do A together first. 11 2/5 minus 3 2/3 minus 11/3 is blank. So this one's just solve it by grouping them together. So let's see what we can do. We can combine our thirds. So let's rewrite this as 11 2/5 minus. Now, we're subtracting both of them, so we actually have to add them together before we subtract it from the whole. That's going to be a tricky step to try to remember, but you really have to think about that. Oops, I said we were going to add those. So without renaming them right yet, I'm just going to add them together as is. So 3 2/3 plus 11/3 is going to be 3 13/3. And we're going to subtract that from that 11 2/5. Now, I'm not done yet because I want to rename that fraction that's greater than a whole over here, the 3 13/15. Whoa, that looked weird. Whoa, what is happening, Briggs? There it goes. We're going to work with that and rename it. So if we count by threes, 3, 6, 9, 12, we know that there's 12 thirds, which is 4 wholes, and that there would be 1/3 left over. So if we think about that, well, 4 plus 3 is 7 and 1/3. So really we're subtracting 11 2/5 minus 7 and 1/3. Okay. Well, these are the kind of questions we were working on this week, right? So now we need to create common units and subtract. So 15ths would be our common unit. And multiply by 3, so that'd be 6/15. And on the thirds, we're multiplying by 5, so it'd be 5/15. And now we can subtract. Well, 11 minus 7 is 4. 6 minus 5 is 1. 15ths are going to stay. Our answer is going to be 4/15. Let me just double check to make sure I did that right. Perfect. All right, and perfect works, as my dad used to tell me. All right, now this one's the one where it's more like algebra, where we're like, solve for the question mark or solve for the variable. Well, I see, remember, we're going to add these together and then subtract 15 from it and see what we're missing to get that. So let's work through this. We're going to put this in parentheses, 11 7/8, and we're going to add 3 1/5. And then we're going to subtract 15, and that's going to give us what we're looking for. So now if we think about this, well, we got 11 and 3 that we can easily add that, the ones together, but we have 8ths and 5ths. So let's count by 8ths. 8, 16, 24, 32, 40. The first time that we landed on a multiple of 5 is 40, so we know that it's going to be 11 40 something 40ths plus 3 something 40ths. Now let's think about what we're multiplying by. Well, 8 we multiplied by 5 to get to 40th, so 7 times 5 is going to be 35. 5 times 8 gave us 40th, so 1 times 8 is going to give us 8. And let's finish writing our sentence. And add that together and get an answer and subtract 15. So 11 plus 3, well, that's going to give us 14. And 35 plus 8, well, that should give us 43 40ths, right? And then we're going to subtract 15. Well, we need to rename that fraction greater than a whole. Let's pull out 40 40ths and add it back to the whole. And that should leave us with 3 40ths left over. And then we subtract 15. Our answer that we're looking for is just 3 40ths. So that's the missing part. Great job. So pause me and I'm going to write down the answers for the questions above. And then please check yourself and do your best. All right, please check your work. I just wrote the answers. I did not show the regrouping of our like units and doing it mentally. But I would like to see the work on your exit ticket, please. Please let me know if you have any questions about today's lesson and we can connect. All right, good job. Be prepared for a module assessment when you're in person. Um, Distance learners, you can choose to do it Thursday or Friday, but there will be some sort of review on the opposite day that you're not working on the assessment. So if you're home tomorrow, you'll have some multiplication fact practice along with some fraction practice, and then on the day that you come in, we'll reverse it for the other people. All right, so good job today. Let me know if you need any support.